quantum continuum, bridging discrete and continuous. The quantum continuum is a concept in quantum mechanics that explains how particles, like electrons, can behave in two seemingly opposite ways at the same time. They exist as discrete states, like an electron jumping between energy levels, but are also described by smooth, continuous wave patterns. This idea helps us understand the strange and beautiful way the universe works at its most fundamental level. Key ideas in the quantum continuum. Discrete states. Imagine climbing a ladder. You can only step on individual rungs. This is like the quantized energy levels of an electron in an atom. These are fixed, specific states that particles can occupy. Continuous framework. Now imagine that between the rungs, there's an invisible, smooth curve that connects them. This is like the wave function that describes how a particle spreads out and behaves as a wave. Together, these two ideas, discrete and continuous, form the quantum continuum. How the quantum continuum works. Particles as waves. Particles like electrons aren't just tiny dots, they behave like waves. This wave-like behavior is described by a mathematical function called the wave function. The wave function evolves smoothly over time, like ripples on a pond. Energy levels are quantized. When electrons are bound, like in an atom, they can only have certain energy levels, like the fixed notes on a piano. These energy levels come from solving equations that describe how waves behave. Probability rules. The wave function doesn't tell you exactly where a particle is. Instead, it gives probabilities. Squaring the wave function gives you the chance of finding the particle at a particular spot. Why the quantum continuum is fascinating. Fourier transform. Quantum mechanics uses a math trick called the Fourier transform to show that particles can behave like waves in both position and momentum. This is why a particle can act like it's in two places at once. It's all part of the continuum. Boundary conditions create quantization. When particles are confined, like in a box, their waves have to fit perfectly within the boundaries. This creates the discrete energy levels we observe. Uncertainty principle. There's a trade-off. The more precisely you know where a particle is, the less you know about its momentum, and vice versa. This is the famous Heisenberg uncertainty principle. Why does it matter? The quantum continuum connects the dots between the abstract math of quantum mechanics and the real-world behaviors we observe. It shows how the universe is both orderly and unpredictable, bridging the gap between two seemingly opposite ideas. The bigger picture. The quantum continuum isn't just about physics, it's a way of thinking about the universe. It reminds us that even the strangest, most counterintuitive ideas can have an underlying logic. Understanding this concept can inspire us to see the connections between the finite and the infinite, the simple and the complex. The quantum continuum reveals a profound truth about the universe, that simplicity and complexity, order and chaos, discreteness and continuity are not opposites but parts of the same cosmic tapestry. It challenges us to think beyond boundaries, showing how the universe operates on principles that intertwine the finite with the infinite. As we embrace this concept, we gain not only a deeper understanding of quantum mechanics, but also a new perspective on the interconnectedness of all things. The quantum continuum invites us to explore, to question, and to marvel at the elegant dance of particles and waves that defines reality itself. Thank you for diving into this fascinating journey through the quantum continuum, where science meets philosophy and the mysteries of existence come alive.
In the silence of the cosmos, a ripple in the stream, particles and waves collide in a quantum dream. Boundaries dissolve, the lines blur away. Where finite meets infinite, they dance and sway. Discrete steps on an endless stair. Energy jumps, but the waves are there. From the depths of the unseen, a rhythm so true. The quantum continuum calling to you. Particles collide, waves intertwine. A universe unbroken by the threads, heads of time. From the smallest spark to the cosmic view, it's the quantum continuum binding me and you. In the depths of the atom, secrets unfold. A story of chaos, a truth to behold. The curve of the wave, the rise of the peak. In the infinite void, its existence we seek. Steps that echo through the void of space, a timeless waltz, a boundless place. Feel the harmony, the pattern so fine. The quantum continuum, it's yours and mine. Particles collide, waves intertwine. A universe unbroken by the threads, ebbs of time. From the smallest spark to the cosmic view, it's the quantum continuum binding me and you. Energy flows where the boundaries meet. Infinite pathways beneath our feet. The notes of the stars, the chords of the light, play the song of existence, a symphony bright. Particles collide, waves intertwine. A universe unbroken by the threads of time. From the smallest